All right, guys, welcome back to Chapter 7 of Scripting for the IT Professional. So, today we're going to change our topics a bit. Today, we're going to talk about the absolute foundation of all scripting and automation on most systems. We're going to be talking about command line. Specifically, we're going to be talking about the Bash shell. So far, you have interacted with the computer mostly through the graphical interfaces, but today we're going to be focusing mostly on command line interfaces, or CLI. Remember, think of it as learning as the native language of the computer. So when we want to automate a task, we don't just tell the computer what to do by clicking buttons, but we're going to write the script. Now, using this language, we're going to try to figure out how do we interface mostly with Linux operating systems. So Linux has a term called a shell, and so you might be wondering, what is a shell? The simplest way to think about it is the shell is the translator. You type in a command that you understand, like list my files, and the shell will translate that into an instruction to the computer, the kernel, and then execute those commands. When you write a script, you're just writing a list of commands for the shell to translate one by one. And I do remember that it is one by one sequential top to bottom. As I said, you're already familiar with GUIs, otherwise known as graphical user interfaces. This is when you point and click, pretty easy. They're great for doing a single task at once. But what happens when you need to rename 1,000 files all at once? Clicking would take forever, okay? This is where the CLI, the command line interface, will shine. It's built for repetition. It's built for precision. It's built for automation. You can type a single powerful command and do that task in seconds. And even better, you can save that command into a file, aka a script, and run it whenever you want. There's different types of shells, though. Just like there are different human languages, Bash is the most common and most popular one. It stands for Born Again Shell. By learning Bash, you'll learn the dialect of automation that is understood by almost every Linux operating system out there. So why are we going to focus on Bash? Well, 3 reasons. First of all, it's everywhere. It's the default Linux and default on Linux and Mac OS, and is actually easily available even on Windows. Any script you write in Bash will likely run on any server you connect to. Second, it's incredibly powerful. It's great for managing things like files and running programs and the system kernels themselves. And the most important for us, by learning Bash, this is going to be the first and most critical step of being able to write the scripts that we need to do for an IT professional. Every command you learn today is just a word, and you can use it in an automation script tomorrow. So let's just start learning what Bash is and how to use that. So before we actually write a script, we need to manage the files within a Linux operating system. The script needs to know where it is and how to get to the files it needs to work on. So the place that your shell is currently located is called the working directory. Now, we need to learn how to navigate in order to make our scripts, well, to write any scripts, really. So Linux and Mac OS recognize everything into a big tree. It's a hierarchy. Now, even Windows does this, but in Windows, we do it a little bit different. In Linux, we do everything from the root directory. The root directory is denoted as a /, okay? Now, the / itself is the root directory, but our personal files are stored in what we like to call our home directory. It's a handy shortcut, and we use the tilde symbol to see it. So if you want to see where your home directory is, all you do is you use the tilde symbol. The next command will be pwd. Pwd stands for print working directory. It is your you are here map is the way I was thinking about it. If you get lost, you can always type pwd, hit enter, and you can see, well, where are you currently located. It's also a great tool for debugging. So here's an example, pwd, maybe I'm in home and then my username. The ls command lists the contents of a directory. A script might use ls to check to see if a certain file exists before it tries to do something with it. For example, maybe we want to list the files and see if we can see results.txt and then email it to me. So ls is a very simple command that just says, hey, list me everything that's currently in the directory I'm in. Now we can modify our commands by using option flags. Option flags, or just like in Windows or any other operating system, are very common if we want to give more detail or different detail with a command. Like for instance, on an ls command, we can use -l to give us a long list. This will give us like file sizes and permissions. We could do a -a for all entries, even if they're hidden. We go -h to do human readable instead of just seeing bytes. Bytes are kind of hard to do math with, but if I see that it's 1.2 megabytes, maybe that makes more sense to me. And we can use this information to like maybe check the size of a log. Now, we do want to sometimes move around, so the cd command is for change directory. It's probably the most common command you'll see in a script. Often the first line of a script is to cd into the correct project folder to make sure that the rest of the script's commands run in the right place. Okay. Now cd does have a couple different special paths. You'll see these shortcuts all the time. cd ... means go up a level. cd tilde means to go back to your home directory, or cd dash is a neat way to go to the last directory that you were in. Now, tab completion is going to be your best friend with bash, okay? Now, tab completion is a shell feature that lets you auto-complete commands and file names. This won't run in your script, but is definitely your best friend when you're trying to write a script. It prevents typos on long file names, which are a common source of bugs within our scripts. Now that we've gotten to the core of what many automation scripts are going to need to do, create, copy, moving, deleting files and directories, let's actually take the action verbs of all of this. Okay, let's figure out what those commands are. A setup script for a new project normally is going to be make directory for my project. mkdir makes a new directory. The -p will also create parent directories if needed. So make directory -p project /data/raw tells the command, hey, if the parent directory doesn't exist, create those two while you're at it. Now the touch command, on the other hand, is a good way to create a file that's empty. Why is this useful in a script? A script might want to touch a file like processing.log to create it, and then start writing log messages into it as it runs. It's also a great way to make sure that, can the file be created at all? Do you have permissions to even look at a file? If not, this will throw an error. Before you start running a script and trying to process data, you can do some sanity checks to make sure everything's okay. The cp command, on the other hand, is a classic way of backing up scripts. cp is a good way to say simple backup script might be cp-r source to destination. The -r stands for recursive. It's definitely going to be essential when you're trying to back up everything inside of a directory with all of its contents. But you'll see cp quite often in backup scripts. mv, on the other hand, can do one of two things. It's good for moving or renaming. A common pattern in automation scripts is to have the folder have a folder of new files, and the script processes each file one by one, and after it's done, it moves it to a process directory or an archive directory. Well, if in order to move the file, we need to know the command. Okay? Anything that hasn't been moved to process or archive lets us know that it hasn't been processed yet. It's a great way of doing data processing and create a new pipeline. The very cautious rm command. This is the most important slide in the deck. The rm command deletes everything permanently. There is no trash can. There is no undo button. When you see an RM in a script you downloaded from the internet, you should be very, very cautious. Pause and understand what file or directory it's about to delete before you run that script. In a script, you'll see rm combined with -r or -f for force. The command rm-rf means delete this directory and everything in it. Don't ask me for confirmation, and it's arguably the most dangerous command in all of Linux. It's incredibly useful for cleaning up scripts, but a tiny typo can wipe out your entire system, so please double check the system path. Now, as you start reading scripts, you're going to need to find commands and options that you've never seen before, and that's going to be normal, okay? The most important skill that you have is to learn well, you don't need to memorize every command, but know how to find help, okay? And so a quick and easy way to learn about a command is using the --help. If you see a command in a script like mkdir-p and you've forgotten what -p does, type mkdir-help in your own terminal, and it will give you a quick summary. For the full story, use the man command, which stands for manual. Man ls will bring up the complete official documentation for the ls command. This is your ultimate source of truth when you're trying to understand what a line in a script does. Just press Q to quit when you're done, and that's it. Now, man pages can be very, very long and hard to read because there's just a lot of information. So practicing using a man command and knowing how they're configured is definitely something I recommend. Now, file permissions in Linux is a little bit different. So let's break it down quite simply. R is for read. What can I do? What can I see in this file? W is for write. Can I change this file? And X is execute. Can I run this file as a program or script? For our purposes, the X permission is the most important. A file is not a script until you give it execute permissions. Okay? The chmod command is a way to change mode. Change mode is, well, how you change these permissions. When you download a script from GitHub, it usually won't have execute permissions by default, okay? So you have the first thing you need to do is make it executable. By doing chmod, u plus x of myscript.sh means change mode, the user add execute permissions to this file. And you'll do this every time you write or download a new script, so something to get used to. So let's recap. Today we learned about basic vocabulary on the command line. You know how to navigate and manage files, get help, but most importantly, you understand that these commands aren't just for typing one at a time. They're going to be the building blocks that we use to combine in a file to create a script that automates complex tasks. You now have the foundation to start reading and understanding basic scripts, and we'll continue learning as we go through. Make sure you go through the chapter itself. Make sure you go through the labs, because in this chapter, more than most, the lab is really where you're going to get that muscle memory to make sure that you truly understand. All right, well, thank you again, and I'll see you for the next chapter.